Welcome to example number 3. We have two gliders that are moving along a frictionless air track. That way we don't have any external forces acting on the system. Glider A has a mass of half a kilogram, while glider B has a mass of only 0.3 kilograms. Both gliders move with an initial velocity of 2 meters per second. One is to the right and one is to the left. So you can see there's a negative value here. So when you solve problems as such, what would be very helpful is to draw pictures. At least have the picture of the before and then the picture afterwards. And then that way you can clearly list what you know and what you don't know. So you can write in with the pictures the mass of A, mass of B, velocity of A initially, velocity of B initially, and then you could write down at the end the velocity of A finally you don't know, but we are told that after the collision glider B will move to the right with a velocity of 2 meters per second. So to solve this problem, we're going to be assuming, since there are no external forces acting on the system, that the momentum of the system initially and the momentum of the system finally remains constant. So we are going to be using the conservation of momentum. So you write momentum initially equals momentum finally. Now we're looking for the total momentum of the objects before the collision. So really the system is really the two bodies together. So we're going to add up their individual momenta. Really you could think of this as the momentum of object A initially plus the momentum of object B initially must be equal to the momentum of object A finally plus the momentum of object B finally. So you could probably go straight to mass A, velocity A initial plus mass B times velocity B initially. And then over here finally we have mass A times velocity A final plus mass B times velocity B final. So then at this point you substitute the numbers in. So we have 0.5 times 2, and then we have 0.3 times negative 2 equals 0.5 times this unknown final velocity of A plus 0.3 times velocity B final, which is 2. So this is going to give you 1, then minus 0.6 equals 0.5 VA final plus 0.6. So let's all combine all the numbers on one side. Let's say the left side here. So we have 0.5 VA final, and we have a negative 0.2 on this side, which will then divide by 0.5, and VA final will come out to be negative 0.4 meters per second. And the negative is indicating that it is moving to the left. Common mistake that people typically make with number 3 is really forgetting that momentum is a vector and making sure that you've got the signs appropriately drawn in. So I think it's important to draw pictures, define your coordinate system that x is going positive, say, to the right. That way when you indicate your velocities, you have the plus and minus signs in the appropriate places and you won't make mistakes with that. The second part of the question is asking if the collision is elastic or inelastic. Now, if you remember, the difference between an elastic and an inelastic collision is that the elastic collision is the only one where the energy is conserved. Now, the energy that these gliders have are kinetic energy. So really what we want to do is we want to compare the kinetic energies of the bodies before and afterwards. So let's calculate the kinetic energy of the system initially. That would be using 1/2 mass A times velocity A initially squared plus 1/2 mass B times velocity B initially squared. So that would be 1/2 times 0.5 times 2 squared plus 1/2 times 0.3 times negative 2 quantity squared. So this kinetic energy initially is 1.6 joules. And then let's check the final kinetic energy using 1/2 mass A times velocity A final squared plus 1/2 mass B times velocity B final squared. That's 1/2 times 0.5 times the velocity we got earlier, which is negative 0.4 squared plus 1/2 times 0.3 times velocity of 2 squared. And that will give you a kinetic energy, finally, of only 1.04 joules. So, the final kinetic energy is less than the initial kinetic energy. That means some of the energy was lost, probably due to heat. So it is inelastic, the collision. And that's it for this example.